My name is Jonathan. I am a teacher support representative here at PASCO Scientific, and today I'd like to give you a brief introduction to the Zeeman Effect apparatus. There are many components to the Zeeman Effect apparatus. The main parts are your power supply, the electromagnet, and then all of these components which come in this very convenient case for storage. I'm going to put the case away for right now so we have some room on the table to work with. So I've already pulled out all of the optical components, so what I'm going to do right now is show you how you set this up all together, and then we will go take a look at PASCO capstone later to see how you can make your measurements. So to start off with, we'll go ahead and connect the electromagnet to the power supply using the included banana cables. The next thing we want to do is to take our mercury lamp and insert it between the coils. And you want to be careful not to touch the glass envelope of the mercury lamp. The next part is installing the track and the components on the track. You have a block that you can place next to the electromagnet, and as you can see there are fittings so that you can align the electromagnet with the optical track very easily. Okay, now from here we can go ahead and put on our first optical component. So the first thing we're going to use is a lens and a polarizing filter. The holder that you want to use for that is the one that has this horizontal adjustment on the bottom. So to start off with, I'm going to go ahead and put a post on it. And we're going to take one of these stands and put these together. Post just go ahead and slides right in there like that, and then we'll go ahead and slide that onto the track. Now we want to have the lens on the same side as the electromagnet and the same side as the adjustments. So just screw that down and hold it in place. Polarizer goes on the other side. And we'll screw that down, but we don't want to screw this one down all the way because you want to be able to move the polarizer. Now as far as placement on the optical track goes, the lens has a focal length of around 13 centimeters, so you want to have it at least 2 focal lengths away from the mercury lamp. A good place to start is around the 30 centimeter mark on the track if you place 0 right here. So I will go ahead and put it at that location. Alright, so the next component that we're going to put on here is the Fabry-Perot interferometer, and also a filter that only allows the spectral line of 546.1 nanometers to get through. So we'll take the next optical holder and place the interferometer into that, placing it on the opposite side of the XY adjustments that you have on this holder. And we'll screw that down. And then on the other side, the filter just goes ahead and just screws right in. As before, we have our mount that we can screw together. And a post that screws into the optical holder. slides right into the stand. We'll go ahead and slide that onto the track. Now as far as placement goes, where you put the interferometer needs to be on the opposite side of the electromagnet. And as far as distance goes from the polarizing filter, the general rule of thumb is that you don't want to have it too far away. We recommend about 10 centimeters away to start off with, and you can make your adjustments from there. And then the last thing that we want to put on is the camera. So again, we get the stand that we need to put together. The camera consists of two parts, the lens and the sensor. And the post screws into the camera, and again just slides right onto the holder. Now, as far as the placement of the camera goes, I find that having it closer to the interferometer is better. You tend to get brighter lines that way. So you can probably put it as close as you can without actually touching the interferometer. Now from here, what we need to do is we got to make sure that the height is aligned with the mercury lamp. So to do that, we'll take a meter stick, and you can go ahead and measure from the tabletop to right where the center of the iron core is, because that's about at the same height as the mercury lamp. So from what I can see from here, it's around 19 centimeters. So I want to make sure that each optical component is at a height of around 19 centimeters. It doesn't have to be quite exact, but of course the closer the better. And looks like we have about 19 centimeters right here for the lens. And for the interferometer, I'm going to have to raise that up a little bit. So I'm just going to go ahead and loosen the post. Actually, looks like I need to screw that in a little bit better, make that a little tighter. I'll raise the post a little bit. And you can also adjust the height. Oops. Give me a little grief here. Okay, there we go. Alright, so we can also adjust the height by using the stand. You can rotate the adjustment on the stand and you can get your height a little bit more precise that way. And then we'll go ahead and do that with the camera as well. So I'll just go ahead and raise it up a little bit and then do my fine adjustment with the stand. And of course, measuring as I go along to make sure that each one is at around 19 centimeters. Another adjustment that is recommended to make is if you take like a textbook or something very flat and then place it against the lens and against the interferometer, just to make sure that they are also vertically aligned. That will help with your getting the best possible interference rings that you can with the Capstone software. So from here, we can go ahead and turn on the lamp and the coils, and also connect your camera to your USB port on your computer. And from here we'll go ahead and take a look at what we see inside of the Capstone software.